More than 15,000 years ago, long before the rise of cities or empires, long before recorded history, a momentous journey began, one that would forever alter the human story. Across frozen landscapes, coastal waters, and uncharted wilderness, small groups of people pushed beyond the edges of the known world. They didn't know they were making history. They were simply following food, searching for shelter, and seeking a better life. But in doing so, they became the first humans to set foot in what we now call the Americas. For much of the 20th century, scientists believed there was only one answer to the question of how humans first reached the New World. According to the dominant theory, people crossed from Siberia into Alaska during the last ice age via a land bridge known as Bering. As glaciers locked up vast amounts of water, global sea levels dropped by over 300 feet, revealing a massive stretch of land connecting northeastern Asia to the Americas. This land wasn't just a narrow isthmus, it was a vast, windswept plain up to 1,000 miles wide, home to grazing mammoths, bison, and hardy bands of hunter-gatherers. The Bering was more than just a passage, it may have been a homeland. For thousands of years, people likely lived in this region, cut off from the rest of Asia by massive ice sheets and unable to push further east because North America itself was also sealed off by glaciers. During this time, early populations developed unique ways of surviving in harsh subarctic conditions. Archaeological evidence, such as ancient toolkits and genetic clues in modern populations, suggests that these Beringians remained isolated for millennia before finally spreading out. Then, as the climate warmed around 16,000 to 13,000 years ago, the ice began to melt. A narrow corridor opened through what is now Western Canada, allowing movement from Alaska into the unglaciated parts of North America. This ice-free corridor became central to the traditional explanation for how the Americas were peopled. According to this theory, small groups of hunters traveled southward through this gap and began to spread rapidly across the continent. Their signature in the archaeological record? The Clovis culture of people known for their beautifully crafted stone spear points with fluted bases. These tools, ideal for hunting large Ice Age mammals like mammoths and mastodons, appear across the United States and Mexico in sites dated to around 13,000 years ago. For much of the 1900s, Clovis tools represented the oldest known human presence in the Americas. It was long assumed that the Clovis people were the very first migrants into the New World. But science doesn't stand still. In 1976, at a site in southern Chile called Monte Verde, researchers unearthed artifacts that defied the Clovis first model. Charred wood, stone tools, and preserved plant remains dated to nearly 14,500 years ago, at least, 1,000 years before Clovis. This astonishing discovery suggested not only that people arrived earlier, but that they reached the southern tip of South America astonishingly fast. Monte Verde sparked a paradigm shift. It opened the door for the pre-Clovis hypothesis, the idea that humans arrived in the Americas long before the Clovis culture appeared. Since then, dozens of other early sites have been uncovered. In Oregon's Paisley Caves, researchers found human DNA in fossilized feces or coprolites dated to about 14,200 years ago. In Florida, underwater archaeologists recovered butchered mastodon bones and stone tools from the Page Ladson site, buried deep beneath the Ocilla River. The evidence from these and other locations paints a picture of an earlier, more complex wave of human migration than once believed. But if these early humans didn't come through the inland ice corridor because it likely wasn't fully open yet, how did they arrive? One answer may lie along the sea. The coastal migration hypothesis proposes that early people followed the Pacific coastline from Asia into the Americas, using small watercraft to move from one habitable pocket to another. This route, sometimes called the Kelp Highway, would have offered a string of rich marine environments. Kelp forests support abundant food, fish, shellfish, sea mammals, seaweed, and more. Along the way, small beach camps or rocky coves could have served as temporary homes. This theory solves one major problem: timing. Coastal areas were ice-free earlier than the interior corridor. But there's a challenge too: most of those ancient shorelines are now submerged. As glaciers melted, sea levels rose, drowning what would have been prime archaeological real estate. The physical evidence of these early migrants may lie hundreds of feet underwater. Still, not all hope is lost. Sites like Cedros Island off the coast of Mexico and Calvert Island in British Columbia suggest that humans were present in coastal areas by at least 13,000 years ago and possibly earlier. The types of tools found in these places, along with remnants of seafood and hearths, support the idea that people were adapted to marine life early on. But not all theories focus on Bering or the Pacific. One of the most controversial alternatives is the Solutrean hypothesis. This idea suggests that people from Ice Age Europe, specifically the Solutrean culture of France and Spain, crossed the Atlantic Ocean over 20,000 years ago. How? By navigating along the edge of glacial sea ice, using primitive boats or rafts, and surviving on fish, seals, and seabirds. Proponents point to similarities between Solutrean stone tools and Clovis points both show fine craftsmanship and bifacial flaking. However, this theory has been widely criticized. First, there's no genetic evidence connecting Solutrean Europeans to ancient Native American populations. None. Second, there are no known Solutrean sites along the proposed Route Nothing in Greenland, no campsites in eastern Canada. And third, while the tools may look similar on the surface, their technological lineage is quite different. Most archaeologists now consider the Solutrean hypothesis a fringe idea with little support. So where does the evidence point? To find deeper answers, scientists have turned to genetics. Modern genetic studies of indigenous populations across the Americas reveal a consistent ancestry that traces back to Northeast Asia. DNA extracted from ancient skeletons like that of the Anzac child in Montana, dated to about 12,600 years ago, shows clear links to Siberian populations. Mitochondrial DNA and Y chromosome patterns support a small founding population that likely passed through Bering. Some researchers believe there was a genetic bottleneck, a period when the population shrank dramatically before expanding again, possibly during a long stay in Bering before entering the Americas. There's even more nuance. Recent discoveries in Siberia and China suggest that human populations in Asia were more diverse and more mobile than previously thought. Some may have ventured northward and eastward earlier than expected. Others may have followed reindeer herds, drifted with ocean currents, or even used frozen river valleys as natural highways. All of this leads to a compelling conclusion. There was no single migration, no single route, no one group that discovered the Americas. Instead, what we see is a mosaic of movements spread across thousands of years and multiple pathways. Some walked, some paddled. Some settled for centuries in one place before moving on. Today, the legacy of these migrations lives on in the genetic heritage of Native American peoples, in ancient footprints preserved in volcanic ash, in obsidian flakes scattered across desert floors, and in the stories passed down from generation to generation. And while science continues to probe the past, the heart of this story remains deeply human. It's about resilience in the face of uncertainty. It's about curiosity and courage. It's about families venturing into an unknown land, carrying little more than tools, memory, and the will to survive. They did not know they were the first Americans. They simply went forward. And in doing so, they shaped the future of an entire hemisphere.